Okay, so we do need to talk about shifting functions, and this is something that I'm doing for my students for next year, as well as students that are coming back from virtual, so they know kind of what's up. So we're going to be talking about shifting functions, and specifically we're going to be shifting the x squared function. And so by the end of the lesson, what I'm hoping is that once you start to see what happens to the graph and the points of x squared, which is called the parent function in this case, you're going to be able to see by the structure of a function where it's shifting. So you're going to graph each of the following on the graphing calculator, then describe their translation, whether it's up, down, left, right, it's a vertical stretch, a vertical compression, or it's reflected in the x-axis. And it can be combinations of these things, so we will talk about that. So the first function we need to graph is y equals x squared. And we're actually going to do this one by hand. So if you remember, should be familiar with this. I'm going to plug in -2, -1, 0, 1, and 2. And then I'm going to square each of these. So -2 squared, whenever I square -2, I'm going to get back 4. If I square -1, I'm going to get back 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay? So in this case, we've got a set of points that we're going to graph on the xy axis. So I'm going to go grab that coffee, and I want you to try and graph these, and then we will talk about the rest. So hopefully you've had a go at it. So I'm going to graph these in red. So -2, 4 is here. So that's just that first coordinate. So -2 is your x value, and then +4 is your y value. And then your next one is -1, 1. And then your next one, 0, 0. And then we've got 1, 1 again. And then 2, 4. And that is it. That is the function x squared. So that's what x squared looks like. If we go over here to the graphing calculator, you can also graph it in this graphing calculator, which is kind of going to be the focus. So what I'm going to do is I'm actually going to leave x squared here. So he's going to sit there, and his function will be blue. So this calculator is kind of nice in the fact that any value that you plug in, right, it's going to have a color. So the blue function will be y1. So it's always going to be x squared. So any of the other functions, I'm going to type in the y2 place, and they'll both appear here on the axis. Most graphing calculators will do this. The TI-84 Plus, any variation of it, you're going to see that it has these nice little colors. So I'm going to show you how to use it. But let's go back to this scene. And the first guy that's up is x squared minus 2. So you want to be able to graph x squared minus 2. So let's go ahead and graph that in the graphing calculator. So in this other line, what I'm going to do is type in x squared minus 2. We're going to graph both. So if you take a look here, what's going on with that red line is that it's shifting down 2 units. So it's taking every point, and even if I zoom out, this will kind of be the same. And good job, Bigford. All right. Shifted down 2 units, okay? So this function is shifted down 2 units, so it's translated down. So on my sheet, right, for number 1, the equation y equals x squared minus 2, I'm going to note what shift. So the shift is down 2 units. And then I'm going to head back and I'm going to do some more. So the next guy is x squared minus 5. Okay? So x squared minus 5 is going to be my next function. So I go to the graphing calculator and I go to y equals, and instead of x squared minus 2, now in place of that negative 2, I'm going to put a negative 5. So I'm going to graph it. And if you take a look, any negative number at the back of x squared, or at the back of x squared, it's going to shift it down. So negative 7 would shift it down 7 units. Negative 4 would shift it down 4 units. Negative 1 billion would take that quadratic and shift it negative 1 billion units down. So if I take a look here, you can kind of see this is shifting down 5 units. So over here, I'm going to go over here, and I've got graph 2, y equals x squared minus 5. I'm going to note its shift, which is down 5 units. And go back. X squared plus 4 is the next one, so we're going to do that one. So instead of plus 5, I'm going to do plus 4. Graph it. And it moved 1, 2, 3, 4 units up there. Okay? So 4 units up. Okay. So the next one's going to be x plus 3 quantity squared. Okay? So notice that the parentheses around there will be distinct, so they will do something. Okay? So that's something that we need to talk about. But x plus 3 quantity squared is going to do something to this function. So I'm going to write this down here. It's going to shift left 3 units. Then the next one, oh, you need to see that. Yeah, that's important. So let's go over here. It's going to shift left 3 units, so I kind of made the claim, kind of gave it away, and that was my mistake. My head space is kind of elsewhere, but if I take x plus 3 inside parentheses and raise it to the second power, what you're going to see is this function, every point, shifts left 3 units. So even though it's a plus on the inside, what it does is it takes every point and shifts it left 3 units. So what you'll find is that, I like to say this, the outside of the function, whenever you're shifting vertically, so up or down, it works exactly like you think it will. So negative 2 on the outside of the function shifts it down 2 units. Negative 5 shifts it down 5 units. Positive 4 shifts it up 4 units. But whenever you put it inside the parentheses, it shifts different. So number 4 shifts it left 3 units. So it's going to, or yeah, for you guys, left 3 units. So it's going to be the opposite of it. So you're kind of going to, you're going to have to kind of throw intuition away with horizontal shifts. So this is a horizontal shift. So let's do some more. Next one's going to be x minus 5 squared. X minus 5 quantity squared. And so if hopefully your intuition is starting to go away, but hopefully you're starting to see the pattern. That's kind of important here, seeing the pattern. So minus 5. And negatives shift right, okay? So for inside the parentheses, it's a horizontal shift, so it will still shift right. So this is going to shift right 5 units. Oops. Okay, so that's another one. So let's kind of zoom out here. Start with number 6, lesson. So number 6, you'll find x plus 1 quantity squared. So we're going to do that one next. Oops. So over here to our graphing calculator, type it in. Shifts left 1 unit. Okay? So it shifts left 1 unit. And so anything on the inside of those parentheses of that quadratic, it's going to shift it left and right depending on the value. So if it's positive, it's going to shift it left. If it's negative, it's going to shift it right. Positive left, negative right. Positive left, negative right. For vertical shifts, it's going to shift it up and down. So if it's positive, it'll shift it up. If it's negative, it'll shift it down. So horizontal shift, again, works opposite the way you think it does. If it's negative, it shifts right. If it's positive, it shifts left. Okay? So the next one we've got is 5x squared. So let's see what this does to the function. Ooh. Yeah. So we're going to go in here, clear this guy out. 5x squared. So that's 5 times x squared. So that's multiplication. So if I take a look at it, there's the original function. And if you take a look, a lot of people start to say, well, it looks skinnier. Well, think about this for a second. You're taking each output and multiplying it by 5. So think taffy. Is it being stretched up or compressed down? So if I take every point and look at every blue point and then take a look at every red point, it's actually being stretched up like taffy. So this is called a vertical stretch, and it's by a factor of 5. So we're going to say that. So number 7. By a factor of 5. Okay, so this is a vertical stretch by a factor of 5. Then we're going to take a look at the next one, y equals 10x squared. Well, that's a number bigger than 1, so any number bigger than 1 that's not negative, what it's actually going to do to that quadratic, like 2, 3, 4, so on and so forth, even if it's a fraction, if it's 3 over 2 and it's larger than 1, it's going to vertically stretch that function. So we're going to see this. It's actually going to get skinnier than that guy, that red guy. So we're stretched more than that guy. So I don't want to use that terminology, skinny. Don't think horizontal here. Think vertically. Right? If it's on the outside of the function, it's a vertical move. So this is 10x to the second power. So I graph it, and if you take a look at it, it's stretched more. So So a vertical stretch by a factor of 10. That's what's going on here. And then we've got 1/2 x squared and 1/5 x squared. So I'm going to go ahead and write those down for 9 and 10. So I type these in to the graphing calculator, do 1/2 first, and then do then do 1/5. So if I take a look at that, take a look at it. It seems to get wider, and this is like smushing it. So it's not vertical stretch, it's a vertical compression. okay? So it's a vertical compression by a factor of 2. And then we've got 1/5. So we'll just change that 2 to a 5, graph it, and what you'll see is that it gets even smushed even more, okay? So that is a vertical compression. By a factor of 5. That's what's going on here, okay? So starting to learn a lot more about this, so hopefully the next few are actually going to be a little more intuitive. So 11 through, yeah, what, 20? Hopefully they're going to be a little more easier to understand what's going on. So this is going to get into reflections. So let's see if we can get this done. So 11 is y equals negative x squared. I'm kind of putting all these ideas together. So y equals negative x squared. So anytime you see a negative in front of something, like a function, and you're trying to graph it, if you're used to the positive version, right, what it's going to do is reflect. So if you multiply the entire function by a negative, I'm going to show you that this is going to be a reflection, okay? And it's specifically across the x-axis, and that's anytime you multiply by a negative on the outside of the function. So let's go ahead and look at this graphing calculator, and I'm going to clear all this out. We're going to put a negative. Make sure you use this symbol if you're going to use this calculator to do this. The minus sign will not work. It'll get an error. So you get negative x squared, okay? And if you take a look, it takes every point and just flips it over the x-axis, okay? Just flips it over the x-axis. So it takes it and makes every output negative. So if the, right, 2, 4 was a point, then now 2, negative 4 is going to be a point. So make sure you understand that. So that is a reflection. Let's take a look at this lesson. Okay, so the next one is going to be x plus 3 parentheses, so x plus 3 quantity squared minus 5. And this should shift left 3 and down 5. So you can use more than one shift at a time is what this is trying to get at. So, oh, well, so sorry about that. You can get to see that. So I'm going to put in here x squared, and I'm going to do that again. So x plus 3 quantity squared minus 5. What you'll see is that it's kind of hard to see whenever you first start, but it actually shifts left 1, 2, 3, and then down 5. So 1, 2, 3, 4, 5. So I know you probably can't see my cursor, but so this, you can use more than one shift at a time. So this is a horizontal shift, left 3 units, and then down 5 units. So let's write that down. So okay. And let's start to get into some of these other ones. So the next one's going to be x minus 1 squared plus 4. So I type in minus 1 and plus 4 on the outside. So let's see. correctly, and then graph it. And I did not press on graphing calculator, so here you go. So let me do that again. My OBS is breaking. So I go over here to y equals, and if you take a look here, I've got x squared and x minus 1 quantity squared plus 4. I go to graph. And if you take a look here, it is shifting right 1 and up 4. So 1, 2, 3, 4, yeah. So right 1 and up 4. So if I go back to this scene, so right 1 units and up 4 units. Okay, so that's good. And then if I take a look over here again, the next one's going to be 9x squared minus 6. Ooh. So if you remember, whenever we multiply by a number on the outside, what it's actually going to do is if it's larger than 1 and non-negative, it's going to stretch it. So this one's going to be stretched. And then I've got a subtraction of 6 at the back. So if we remember when we subtracted numbers from the back like 1 and 2, it shifted the function down. So what this is going to be, and I'm going to show you here in just a second, but this is going to be a vertical stretch by a factor of 5. And vertical shift by a factor of 9, my bad, it's not 5. Factor of 9 and a vertical shift down 5 units. And so you're going to start to see kind of like these different things together. And you can actually take a look, and I can take a look at that function, right? And you didn't even see the function yet. I can take a look at that function, that value, and just know what it's going to do. So I know it's going to look like the parabola, so that quadratic function. It's going to open up. My a term is positive, so that's going to be important later if you haven't already learned that. And then I know it's going to stretch by a factor of 9 and shift down 6 units. So if I go to this graphing calculator, I'm going to type it in. Graph it, and what you'll see is that it's very, very vertically stretched. So it's vertically stretched by a factor of 9, and its vertex, its turning point, is down 1, 2, 3, 4, 5, 6 units. So it's very, very nice. So we'll do one more, and then I'll leave the rest for you to do on your own if you so desire. And what I suggest you do is just for the others, before you check with your graphing calculator, see if you can figure out where it's going to move. So this one, I know I've got a 1/7 on the outside, so that 1/7 is actually less than 1, so it's going to compress the function by a factor of 7. So I think I'm dropping frames here, but that's fine. So it's going to compress the function by a factor of 7, and if you take a look over here at x plus 1 squared, that's x plus 1 quantity squared, so it's going to shift the function left 1 unit. So we're going to take a look at that. So I'm going to type it in, 1 divided by 7. So it's compressed. It's going to compress the function, not stretch it, but compress it. And it's going to shift it left 1 unit, so it's kind of hard to see, but let's kind of zoom in there. And if you can, yeah, if you can see there, the vertex goes through that point and kind of starts to bend up. So it is compressed and it is shifted left 1 unit. So it is a vertical compression. By a factor of 7. And a horizontal shift left 1 unit. And that's it. That's all I wanted to say for this, so I'll switch back to that lesson just in case you need some extra practice, and I'll let you take a look at these so you can pause the video. So I'll just kind of show you 15 through 20, 16 through 20, and I'll just kind of do 16 and 17 in my head while you're jotting these down if you want to, but make sure you pause the video. But if you take a look here, there's a 5 on the outside, so that's a vertical stretch by a factor of 5. X plus 3 quantity squared, that plus 3 on the inside of the parentheses is going to shift it left 3 units. And then the negative 4 on the outside is going to shift it down 4 units. So it's left 3, down 4, and then it's going to be stretched. And if you take a look at 17, just by looking at it, there's a negative on the outside, just like 11. So 11 and 17, it's going to reflect the axis, and then it's shifted